the functions I have in OTools for converting between oxygen units. And the only two tools I have or the only two functions I have in here as of version 0.14 is a function to convert from micromoles of oxygen per liter to whatever units you want, and then also to convert from oxygen saturation to whatever units that you want. I hope also to have in the near future functions in here to convert from kilopascals or hectopascals, so from pressure units as well, and then probably from milligrams oxygen per liter as well. But for the moment we just have micromoles oxygen and O2 saturation tools at the moment, because those are the ones that we use most in the lab. So to begin off here, let's go ahead and load the OTools library with library OTools command, and then using this read.pyro command that's also in OTools, read in some data that we collected from using some respirometry, using the Pyroscience fire sting optode, and then name that data frame data. Oh, come on, go ahead. There we go. Let's go ahead and take a look at what we have in this this data frame here. We have the date, we have the time in seconds, and then following this we have 4 fields of oxygen measurements, and these were in micromoles per liter, or micromoles of oxygen per liter. We then have the temperature for those 3 different channels as well. We have the pressure. This was the atmospheric pressure that was measured in the base unit of the fire sting, and then other things like humidity, the temperature probe. I'm not exactly sure which temperature probe that is. The internal temperature probes, and some other there that aren't really necessary to us right now. So let's go ahead and take a look at what this this command does. So let's go to help, and let's actually look at the help file for the micromoles O2 per liter conversion tool. And if you come down here to the usage, what you'll see here is that inside this function we're going to require the value. This is the value of that you measured oxygen in, the micromoles O2 per liter. Then it's going to require salinity, which the default in here is 32 parts per thousand. Set that as the default because that is the common salinity at Rosario Beach Marine Lab where we do most of our work. Temperature is set to 11°C. Again, temperature is going to be recorded in these in Celsius. Again, that's a fairly common temperature for Rosario Beach Marine Lab. And then also the atmospheric pressure is required for this as well. Again, the default here is just 1 atmosphere, or 1013.25 millibars. And yes, this atmospheric pressure needs to be in millibars or hexapascals, or hectopascals, excuse me. So let's go ahead and use this real fast. So type into our code window here, micromoles, capital O, 2, capital L, and then parentheses, and our value, let's look here. Let's take this first value right here in the field O21. Okay, so it's in data $O21, so that is that column that we're selecting right here. And then let's just select the first element there, and that will be number 1. Comma. We're going to keep the default salinity. Let's enter in the temperature, and again it's going to be data $, and let's look at what we have here. The temperature for this first channel is temp1. So we take temp1, and then in brackets again take the first element of temp1. So we're just looking at 1, and then let's take atmospheric pressure. So atmp is a command, or the argument there, and we're going to make that equal to the pressure that we measured in the room, which is just this pressure column right here. And that is going to be data $pressure, and then in brackets number 1. So if we run this right now, we have everything that we need to go ahead and convert this data into different units. And if we do that down here in our code window, you'll see you get a data frame that gives you back salinity, temperature, and atmospheric pressure. These are actually just what you read in, just kind of a reminder. And then we have our converted units. We have oxygen saturation. this in oxygen saturation, or the percent oxygen saturation is 74%. It's about 15 or close to 16 kilopascals. That converts to 158 hectopascals or millibars, 118 torr. And then we give you back micromoles per liter as well. This is the actual value that we read in. And then we also have milligrams per liter oxygen. Okay, so let's go ahead and imagine you just want one of these out. Imagine that was O2 saturation. If we go to the very end of this whole command, after the final close parentheses, if we put a $ in here and put in O2 sat, so essentially what the column name is of the value that you want to get back, we run this again, this will only give us out the O2 saturation. So if we're doing lots of these, and we only want to convert to O2 saturation, we just put the command for that column, or the call for that column at the very end of this command, and we just get back the units that we want. So this is how we would convert from micromoles O2 back into this. Let's go ahead and do that. Let's go ahead and make this, assign this as a command. So this is our data.saturation, so I'm going to just call it data.sat and make it equal to that. So there we have a value for the O2 saturation. To just give you the other command, which is O2 sat, again, O2 sat. The commands for O2 sat, this is to convert O2 saturation into micromoles oxygen per liter. And again, its usage is exactly the same. We simply put in the value that we measured, salinity, temperature, and atmospheric pressure. So let's go ahead and do that. O2 sat, and then inside here, actually instead of putting in data as we did, let's put in data.sat. We're going to go back the other way and see if we can get out the exact same micromoles oxygen that we did before, and then go ahead and just copy the temperature and the atmospheric arguments that we were using before. So here what we're doing is we're using the same temperature and the same atmospheric pressure that we did from the first command, but just reading out the result that we got back. And let's look at how that works. Okay, so we're going back down in here, and you'll notice that this reads out in your command window the exact same type of data frame in the exact same order that we got it before. And what this means is that if you want to go between different kinds of units, this makes it very easy to continue to call the same data frame. But it reads out exactly the same. You'll notice we use a different command and a different input data, but this is the converted unit from what we had read in. So you'll notice that we get out the exact same value that we put in for the last one. 187.76 micromoles oxygen per liter. So, and just to show you that we're not just reading out some dummy variable, let's go ahead and put in data O21 and the first variable and read that back out, and you'll notice we get some really crazy values here, like 400 and some odd for 474 for micromoles oxygen per liter, just to kind of show you that if we put in the same exact data for this one, we don't get the exact same thing out. But if we do put in data.sat, we do get that out. Now, one thing I do want to point out here is that we can put in vectors for each of these, for your value, for your temperature, and then also for your atmospheric pressure. So let's go ahead and show you what that would look like. So let's go micromoles O2L, and in here put data O21. Notice I'm not putting the brackets in the one, so I'm calling that entire column. We're going to go temp equals data $temp1, and then atmospheric pressure equals data $pressure. Okay, so what I'm doing is I'm selecting each of these entire columns, and so what it will do is instead of just converting this very first unit here, it will convert all of them in this column, and it will pair the first oxygen measurement with the first temperature measurement and the first pressure measurement to make a conversion, and then do that again with the second and the third and so on. So let's go ahead and look at what this is going to do. I'm not going to read this directly out to the console. I'm going to make this an object, so I'm going to call this output equals this. Let's go ahead and run that, because this is going to end up being, if you look up here in the environment window, this is 1300, over 1300 observations long, so that'd be a very big chunk of thing to read out here. But we'll use the head command. Head command, when you put an object back in there, only gives you the first line, first 5 lines of that data frame. I'm going to put an output. And go ahead and Control Enter here and send that back down again. So what you notice here, or I guess the first 6, excuse me, we have salinity, temp, atmospheric pressure again, but you notice here what we have is several rows, and this actually goes on not just for 6 but 1325 rows, and we have the O2 saturation for all of these, and the pressure, the partial pressure in kilopascals for every single entry there, and so on. So if we want to do this, and imagine we just wanted to convert all of those values into O2 saturation, again we put $ here, O2 sat at the end of this argument. Let's take out the output equals and run this again, and you'll get out one long vector that has 1325 converted values here. So you do that, and that's exactly what we have. Here are all of those values converted from micromoles oxygen per liter into O2 saturation. And again, we could go using the exact same syntax, just with the other command, go back the other way as well. So let's imagine, let's just do this one more thing here. Let's take out this command and go up here. Imagine I want to add another line or another column into my data set that has the convert values. Pretty easy to do. Just go data $O2 sat equals this vector. These just the command, and then $O2 sat, which just grabs that column with the O2 saturation convert values, and this will give us another column in our data frame that is the converted value. So let's go ahead and run that, and let's bring up this data frame again, and again we have all the same things that we had, but if we go to the very end, the column here that's O2 saturation that has all of the converted values, all of our converted measurements from micromoles O2 per liter saturation. I hope you'll be able to use the commands in OTools to convert between oxygen units, which is really kind of a pain. I hope this makes it somewhat easier.